Today we're taking a look at 7.2, inverses of relations and functions. You guys have seen inverses a lot throughout school. You just don't know that you've actually seen them, or you may not know that you've seen them. When you talk about being able to solve equations and you see a plus 3, how do you get rid of it? You have to subtract 3. Those two things undo each other because they are additive inverses. Same thing when you see that you're multiplying by 5. A lot of times we get rid of it by dividing by 5, but you can also multiply by 1/5. Those are multiplicative inverses. This one with the matrix we don't need to worry about. We haven't talked about it this year. We can also do the same thing with inverses in terms of graphs, relations, and functions. To be able to graph an inverse relation, what you would do is you would reflect it across the line y equals x. That line y equals x is just a diagonal line that goes through the origin. Its y-intercept is 0, and you reflect the points across this line. So you would take a point here, you would reflect it across, it would get moved here. At times it can be difficult to reflect it across the line y equals x, but the nice thing is this is the same thing as just being able to switch the x and the y in each ordered pair that you see, and we're going to see how that actually works here in the next slide. This right here is the big idea of the section, is when we talk about being able to find inverses of really an equation, of a graph, of a table, all we really have to do is just switch the x's and the y's. So let's take a look at talking about being able to do some graphing of these. So graph the relation connects to the points, graph the inverse, identify the domain and range. So we start off by saying here's our table. We go through, we plot these points. 0, 2 is up there, 1, 4, here 2, 5, 4, 6, and 8, 7. There's our 5 points. We need to connect these points, so we just draw a curve that goes through these points. There's the graph that we're talking about. That's our original graph. Now, if we want to go through and talk about finding that inverse, well, you have two options. You can really take it and reflect it over that line, y equals x, which is going to be this line, but that may be a little bit difficult to reflect those points. The other way that we talked about is literally just flip the x's and the y's. You're going to switch them. So 0, 1, 2, 4, 8 would become the y's, and 2, 4, 5, 6, 7 will become the x's. And when we graph these, we should see them be reflected over this line. So the point 2, 0 is right there, the point 4, 1, 0.52, 6, 4, that was 5, 3, 5, 2, 6, 4, and 7, 8. We draw a curve through that, and if we take a look, each one of these points is really getting reflected across this line. And this one here, the last point on the function was underneath that line, gets reflected over that line. And that's all that we really have to do to be able to graph an inverse, is we take those points, whatever that coordinate pair is, that ordered pair, we just have to switch the x and the y to be able to get it. So the domain and range of the function, if we go through and we talk about these just how we did on the last section, writing it out in set builder notation, our domain, if we want to start off set builder notation, we do the bracket, the x with the line, the set of all x such that, and then we have our inequality here. Well, if we take a look, our original function, which was this one here, and it may help us out to actually go through and label which one was which our function we can just call f of x here. So there's f of x. What was our domain, as in what was the span of the x's that we saw, which the x's basically started here and the x's ended here. So they started at 0, they went to 8. So we had all of these values covered between 0 and 8. Easy way to write out that interval is we had all of our x's between 0 and 8, and we can just put the inequality symbols that less than between it, saying 0 is less than x, or in this case x is bigger than 0, x is less than 8. But since we had points on 0 and 8, we can put that the or equals to underneath those inequality symbols. We can do the same thing for the range. Range talking about the y, so we'll just change that variable over the y. The range this time, talking about from here to here. Well, it starts at a 2 and it works up to 7. So we had all the y values that were between 2 and 7. And there's our range. For the inverse, if we want to be able to label the inverse, the way that we would write this out to relate it to the function f of x is we would describe it as the inverse of f of x. So the way that we write that out is we use the f of x, but after the x, we put a little -1. That -1 doesn't mean raised to the negative first. That is talking about the inverse of f of x. The -1 is implying the inverse. The f of x is telling us that it's related to this function here. So the domain and the range of our inverse. So we want to look at the inverse function, which is going to be that bottom function now, and say what's going on here. Well, look at where the x's start. They start here, and the x's are going to end here. They start at 2, they end at 7. So this time, our domain starts at 2, ends at 7, and it's all of those values between it. There's our domain. And for our range, talking about the y values that we have, well, now for this, our range, the x's are starting at 0, and they go all the way up here, all the way up to 8. So we have all of the y values now between 0 and 8. If you take a look at what we wrote out for this one here and this one down here, we said to change from the function to the inverse function, all you have to do is switch the x and the y. Well, the domain is just a collection of x values. That's all it's talking about, is the collection of x values. Well, if we flip the x values and they now become the y, take a look at what our range is. It's the same exact thing. It just got flipped over from the x's to the y's. Same thing goes. For the original function, our set of y's got flipped over to be x's for the inverse, so they get flipped over to be the x's. That's why the domain of the one is the same as the range of the other, because we're just switching the x's and the y's, and it works for both of those. It's going to work like that every time. That's why what we said back here, this was the big idea, because we can use this for more than just talking about being able to flip it over the line y equals x. We can use it for domain and range. We can also use it for equation writing. We've already talked about what's up at the top there, saying that this is the inverse of the function by seeing that -1. But if we want to talk about being able to find the actual inverse function, all we have to do, again, is switch the x and the y. That's all that you need to do. So this original function, f of x equals x plus 2/3, is just going to be y equals x plus 2/3. Well, if we want to solve this, we flip the x and the y. So it's going to be x equals y plus 2/3. We get the y by itself. That means get rid of the 2/3, subtract it, and we get y equals x minus 2/3. And the way that we can write this out to represent it as the original function here is we can say the inverse of f of x is going to be equal to x minus 2/3. And there's the inverse function. We can do the same thing with this one over here, with just going through and flipping the x and the y. So we take this, we're going to go y equals x over 4 minus 5. Flip the x and the y, so x equals y over 4 minus 5. Get rid of the 5 first by adding it to the other side. And then we have to get rid of that dividing by 4, which means we multiply by 4. So we have to multiply both sides by 4, meaning we have to multiply this entire thing by 4. So it's going to become 4x plus 20 equals y. So our inverse function here now is going to be 4x plus 20. All right, this one here we're going to hold off on. I want you guys to attempt this one as your homework, and we'll come back tomorrow and we'll take a look at it. All right, we can do this with the graph as well. Is if we're talking about being able to go through and graph this, we can talk about the original function, y equals 2/3 x plus 2, and we can go through and graph this one. This is already in slope-intercept form because it's a line. We can start off with our y-intercept, which is the b, plot the b, and then we can use that 2/3, which is our slope, rise over run, rise 2, run 3, rise 2, run 3. And that's going to give us enough points to be able to say that we can go through and draw a line that goes through that one. All right, to find the inverse then, to actually go through and find the inverse function, we have a couple options that we can go through. One, talking about writing the inverse, this one we really just have to flip the x and the y around. So x equals 2/3 y plus 2. Get rid of the 2 by subtracting it. And then options here is to get rid of 2/3. You can divide by 2/3, which wouldn't be that pretty, but we can also multiply by the reciprocal, what we talked about at the beginning of this multiplying by the multiplicative inverse, we can multiply by 3 halves. So when you multiply both of these by 3 halves, this is going to become 3 halves x minus 3 equals y. There's our inverse function, so the inverse of f of x. We can graph this the same exact way. It's a minus 3, so it's going to start down here. And then we go rise of 3, run of 2, rise of 3, run of 2. And if we do this one more time, we'll actually see that those two lines intersect at a nice point, and we can go through and draw a line that goes through these two. And there's the inverse function. We actually had another option. We talked about being able to say all you have to do is switch the x and the y, that if we just had to graph this right here is the point 0, 2, that we could literally switch the x and the y and graph the point 2, 0, which would be that one. This here is the point 3, 4, that we've switch the x and the y and it becomes a point 4, 3, which is why this one doesn't really move. It's the point 6, 6, which when you switch the x and the y, it still remains the point 6, 6. The other thing to take a look at is if we wanted to talk about that line y equals x, we could draw that line y equals x in there, and we could see that these points just get reflected across. But the two ways that we want to do this one is get that equation and then just go through and graph that equation, or once you graph the original equation, take those points, reflect them across. The last problem that we're going to work with here is a word problem. A store was selling a digital camera which included a gift wrapping charge of $3 and 8% sales tax. The sales tax was charged after the gift wrapping. Write a function that determines the total cost a customer would pay and its inverse function. Explain what both functions would allow you to find. So, first thing we're going to start off with is we need to write out an equation for this. It says it includes a gift wrapping charge of $3 and 8% sales tax, but the sales tax is charged after the gift wrapping. So if we know what the original price was or the original cost, let's just call it C, the original cost. We have to add for a gift wrapping. We have to add $3 to it, and then after that, we are going to add a sales tax charge. Remember, this is like saying that we are increasing by 8%. What we talked about in the last section, you're increasing it by 8%. Well, what amount are you increasing by 8%? 100%. So what we're actually going to be multiplying by is 108% or 1.08, and that is going to equal our total cost. So what this allows us to find, this function allows us to find, is if we know what C is, as in if we know the original cost, what it allows us to do is to find the total that we would be paying. The other part of this is going through and talking about being able to find its inverse function. Well, to be able to find its inverse function, we just have to switch these around and go through and solve them. This one, I want you guys to do on your own. So this is going to be the second part that we have as a homework, is I want you to finish out the rest of this problem.